Alright, finally. Okay, chain rule. This is your bread and butter of the calculus course. So, like I told you, the first sack that you have is technically covering 7 or 3/4 of what you need to know, because there's only 4 areas to study, and you've done your functions. There's still other parts of functions that you haven't learned. Chapter 7, polynomials. Chapter 4, Chapter 2, matrices. Those are all parts of it. Chapter 3, transformations. You need to know that for the first area of study. But the second one is calculus. Under calculus, you have all the techniques: chain rule, product rule, quotient rule, power rule. All those are in there. And then you've got Chapter 10, applications: turning points, stationary points, parallel, perpendicular, intersections, greater than, less than inequalities. So that's what calculus has, but also integration. So one of the top skills that you get from Chapter 9 that you're likely to use for almost every function you can think of is chain rule. Hence why it's the bread and butter. Because chain rule, you can apply that to all functions. All the functions that you learn: sine, cos, tan, log, exponential, any polynomial, you can use chain rule. And that's why when examiners make a question, it's likely you'll be using chain rule a lot of the times. If you're not using it in exam 1, then you'll definitely be doing it in exam 2. If you're not doing it in question 1 of exam 1, then you're likely to do it in question 9 or 10 of exam 1. It's just one of those questions that it's like saying, can you avoid multiplication? Yeah, you're likely to use multiplication in every single question you do. It's the same thing with chain rule. It's likely you'll be using it for any calculus questions. Yeah? So, if you don't get your head around this, what I'm trying to say is you'll find it very difficult to move forward without having chain rule. Yeah? Alright, so I'm going to try to teach you the gist of chain rule, and then you'll find that in the next session I'll be whipping through F, G, H, I, because it's the same rules, but you're applying chain rule to them all. So if you can't do 9E, you'll find that doing 9F, 9G, 9H, 9I is going to be a smack in the face. Yeah? I'm doing that with the next class, and it'll be recorded, so if you want to watch ahead of time, you can too. Okay? But here we go. Chain rule. Let's have a look at what we learned last year for chain rule. Okay? Now up on the right-hand side there, that's your chain rule formula. dy dx, which is what you want, the change of y over the change in x, which is really just saying, d stands for delta, means change. And it's like saying y2 minus y1, that's your change, because you went from y1 to y2. So you're going to see what's the change vertically as you go across. Yeah, so it's the ratio of your vertical height to your horizontal length. Yeah, it's just the ratio. It's like cups of water of cordial to cups of water for rice, or whatever, cups for rice. Yeah, it's the same idea. It's just talking about quantities. How much does x change as y changes? And in this case here, it's saying it's equivalent to dy du times du dx. So the question is, what is du? Because we're familiar with y and x. Y is your vertical height, x is your horizontal. So what's u? U is what your skill is meant to be able to do. Your skill is to identify what is the u variable, because we don't know what u is. U is a made-up variable, okay? And u is there to help make things easier for you. The example I'm going to give you, so you can see, if I asked you to find the derivative of 3x to the power 6, a lot of us can do this. This is just power rule. And the derivative of 3x to the power 6 is, Daniel? Fantastic. We simply say 6 times the 3, the coefficient, and then minus the power by 1. That's power rule. Yeah, the first thing that we've learned as a shortcut method to first principles. And we get 18x to the power 5. That was easy. That was quick. Then I give you, let's say, y equals root of x. Some of us may find that difficult because we forget our index laws. But in this case here, how would you differentiate y equals root of x? Can I please have, let's go with Rachel. Fantastic. It is x to the power of half. Yeah, absolutely. Okay, and that technically what you're just doing there, this is exercise 9F, which we haven't touched, but you see, what I'm trying to say is you're using the power rule. 9F is called rational powers. Yeah, so you've got a fraction as your power. But same drill, you're popping down the half, times the coefficient, x to the power of half minus 1, and you get negative half. But we don't write, in year 12, we don't write with a negative power, so you'd rewrite that as 1 on 2 root of x. If that was a bit fast for you guys there, I'll just write it down again. That's like saying half times x to the power negative half. But we know if it's a negative power, you can write it as 1 over x to the power positive half. But we know positive half is the same thing as root of x. Okay, that's how I got 2 times root of x on the denominator, if you're confused. Okay, so now that we got that, so those two were easy. You had no issues because, and this is the main part here, x was an individual term. You are okay using power rule because it's that, whatever the power is, minus by 1. It was that to the power of whatever it is, minus by 1. It was only one term. So what is chain rule, and what's that du? U is a variable that you don't know. U is a variable that you're going to make up, and you're going to replace whatever the issue is. So whatever makes this problem harder, you're going to replace it with something that makes it easier. And this is what I mean. Have a look at this. I want to take the same problem as the first one, A, but I've made it a bit harder. Now I'm trying to color code it here. You can see 2x minus 6 is very different to x. If I had given you 3x to the power 6, you're like, yes, I can do that. That was easy. But as soon as I chuck in 2x minus 6 all to the power 6, suddenly it's like, is it the same? It looks a bit more difficult because there are 2 terms in there. I could put 3 terms in there if I wanted to. I can put a fraction in there if I wanted to. I could have had 2x to the power 3 minus 6 over 3x cubed. I could do that too. Okay? And then finding the derivative of this now becomes more difficult. Only because I've changed whatever it is to the power 6. If this was not there, it was easy. So this is where chain rule comes in. Chain rule says, all right, well, how about we make up a variable? Let's call it u. It doesn't have to be u. It could have been t, could have been z, could have been b if you wanted to. But we're going to call it u. If you call it u, so we're going to say, all right, well, what if I happen to call this u? How does that change my problem? Well, it changes the problem like this. It'll say, well, I now have y is equal to 3. Now, instead of 2x minus 6, I said, let's call that u. So then I will have u to the power 6. So we just made it up. We made our problem simpler by saying, let's pretend that didn't exist. Let's call that u is equal to 2x minus 6. Let's say that. Now, if I ask you to find the derivative of this, it will be the change of y with respect to the change of u. Not x anymore. It's a change of y with respect to u. That's why we call it dy du. Yeah, the change of y with respect to the change of u. So now if I find the derivative of this, we already know it's 18u to the power 5. So we can find the derivative of that. That was easy. So that's what I'm going to do. I'm going to say, all right, well, dy du, it's just using power rule, I can say that is 18u to the power 5. We're like, yeah, too easy. But that can't be the answer because I just made up a variable. This u came out of nowhere. So we have to do something about that. We just made up a variable u. I've differentiated it as if u didn't exist. And then so you have to now differentiate what you made up. If you're differentiating the outside, okay, then you have to make sure you differentiate what you're replacing. So now if I found the derivative of this, which is the change of u with respect to x. Because in this case, I've got u and I've got x. So it's the change of u in respect to x, which is why we call du dx. So the derivative of 2x minus 6, now we can do that. Derivative of 2x minus 6, Aiden? 2. Okay, and what we can see is, well, if we multiply the change of y to the change of u times the change of u to the change of x, technically you can cross multiply or cross simplify. That's why, if you cross simplify it, it's like saying du divided by du is 1, which ultimately you end up with the change of y with the change in x. That's why it works, yeah? So that's why we're saying, all right, well, that means dy dx has to equal to 18u to the power 5, that's dy du, multiplied du dx, which we know is 2. My answer would then have to be 2 times 18, which is 36u to the power 5. Why am I wrong? What did I do wrong? Luke?
You still have u there?
I still have u there. No, u was made up. I made it up to make it simple. That isn't the answer. And in fact, it doesn't even make sense. I said change of y with respect to x. I don't have the x's here at all. That doesn't make sense. So the u is what you made up. You said u is equal to 2x minus 6. Replace it again. put it back in and say, well, the answer should finally be 36, 2x minus 6 to the power 5, and voila. That is our chain rule. Yeah? But the concept I'm trying to teach you, because when we do 9G, 9H, 9I, it's the same thing. You're trying to replace the issue. Okay, so I'll give you some quick examples up here. Let's say in G, you'll be learning derivative of e to the x. So you know one of the rules you'll know, derivative of e to the x is just e to the x. That's easy, right? So we can do that. How do you use chain rule? What they'll do in the exam, they might do something like this. Y equals e to the power of negative x squared on 4. And they say find the derivative of that. You see, the first one we can do, we know the rule, 9G, but how do we use chain rule to replace that? That's the issue. If this was the letter U, it would have been fine. That's what you're doing in 9G. 9H. What are you doing in 9H? It will be y equals, instead of log e of x, and you know the derivative is 1 on x, then what happens if I give you y equals log e of sine of x squared? That is chain rule. Because I'm going to replace whatever the issue is. Does that make sense? So this one we know how to do. This one we don't. Because it's the sine of x squared. We have no idea how to do that. But we'll replace it. It makes it possible. Does that make sense on what chain rule is? Yeah? Alright, let's give it a couple of more to go. Let's try, actually I've done this one. And this one we can do. You can watch that video again too. Or watch the PowerPoint. Let's try this one. Okay, I'll do the first one, you do the second one. Yeah, the second one's easier. Let's have a look at the first one, A. The problem here is, if I were to write this all in terms of its powers, this is the same thing as writing 2 bracket x squared minus 2, and square root is to the power of what again? Half. Good. Okay? So this is nice. I can use power rule because it's 2 and it's something to the power of half. As long as I didn't have x squared minus 2, that would have been good. It's like I have something to the power of half, I can use power rule. The problem is I don't have just a variable, I now have 2 terms, I've got x squared minus 2. That's the issue. Okay, because that's the issue, chain rule says, make up a variable. Make up one to make the problem simpler. And we say, all right, well, in that case, let's introduce u is equal to x squared minus 2. What I'm saying is, why don't I just replace, why don't I just replace this with u? If I do that, then that conveniently now gives me y is equal to 2, instead of square root of x squared, I now have square root of u. And that's what I want, because that looks much easier. Now, if I asked you to find the derivative of that, what's the derivative of y equals 2u to the power of half, Zahn? How do you find the derivative of 2u to the power of half? Yeah, fantastic. Drop down the half, so you do the same thing. Drop down the half, half times 2 is 1. And then u to the power of half minus 1. That's what I'm going to do. I'm going to say, all right, I'm going to drop down the half, which is here. Coefficient is 2. U to the power of half minus 1. If you give it a half of 2 is 1. So you simplify that down, it becomes u to the power of negative half. But remember, in year 12, we don't write our answers with the power of negative half. We write it as 1 over. Okay, so 1 over u to the power of half, which is the same thing as saying 1 over square root of u. That's how you write your answer. Okay, but that's with respect to u. That makes sense. dy du. I had a y in there and I had a u in there. So when I find the derivative, it's dy du. Now, if I want to find out the derivative, remember I was trying to find dy dx. I made up this variable. I have to differentiate that variable as well. So du dx is what I'm looking for now. And so since I know u equals x squared minus 2, the derivative of x squared minus 2, Lexi? Close? What did we miss? 2x, fantastic. So du dx is 2x, and we know that chain rule, if we multiply dy du to du dx, the u's will cancel out, and you get what you want, which is dy dx. So that's what I'm going to do. I'm going to say, all right, here's my rule. If I multiply them 2, these 2 will cancel out. I get dy dx, which is the one I want. So multiply them together. I've skipped a step here, but when I multiply by 2x, I'm going to write it in blue so you can see. I'm going to write it in blue. All I'm doing is I'm saying take dy du, which is 1 over the root of u, multiplied to du dx, which is 2x. We know that 2x is a whole number, so you can write that as 2x over 1. That's how I got 2x over the square root of u. But we never leave our answers with u because it was a made-up variable. Therefore, my answer has to be 2x square root of x squared minus 2. Easy? That's how you use the chain rule, and it's the same technique that you'll be doing for every exercise. Now, in year 12, you're not required to do this anymore. Year 11, what I'm doing right now is the year 11 technique. It's how you began last year. But you have to now master this so that you don't have to do all that. Okay, so the next time in your exam, you'll have about 2 minutes to do this. Then your steps are simply find the derivative of this, and you should have, either you might have an intermediate step, you might have had 1 over, maybe you got that step, and then you write your answer, yeah? But none of this is required anymore. Okay, it's just me showing you again, reminding you how to do chain rule, but eventually you'll look at that, you should be able to tell the answer. So for example, that one, I should be able to say, all right, derivative of the power, bring down the 2 times this to the power 2 minus 1. Then I have to find the derivative of u, and I can say that that's 6x. So in my head, or when I write it down right now, it should be 2 times 6x times 3x squared minus 5 to the power of 1. That's the intermediate step. Then you write your answer. Okay? But just to teach you guys, I'm slowly pushing you into that realm where you write out dy du, du dx, but over time you're not meant to do that. Yeah? So by the end of chapter 9, what you should be able to do is, if I said, what is the derivative of 3x squared minus 5 to the power 2, you should be able to do it and tell me what the answer is. Yeah? That's the speed you want. And that will be generally your first question of exam 1. 2 marks. 2 out of 40. 1/8. Okay? Is it 1/8? 1 out of 20. 120. Yeah? It's an easy question, and you could easily get one of these questions here, or that exponential question I gave to you. Those are likely questions that you might get. Yeah? But that's what you're going to be doing for 9E. Cool? All right, I'm just going to put up the answers for the second one, just in case you were confused or still struggling with it. Then we can have a look at the solutions. Hopefully you pick up as we're doing it. But there we go. Oh. There we go. Okay, so same idea. As I said, replace that. Get u squared. Derivative of that is 2u. That was easy. 2u multiplied to the derivative of what you're replacing, which is 6x. So 6x times 2u is 12u. So you get 12u, but it's 3x squared minus 5. Now, in year 12, you always want your answers simplified. Everything has to be simplified. Everything has to be exact values unless stated otherwise. Do you leave your answer as expanded? Don't expand unless you can factorize. Yeah, because in this case here, yeah, you can probably write it out as 36x cubed minus 60x. It's fine too. I'll accept that. I'm just telling you to keep in mind, wherever you can factorize, do it. Okay, those are generally the better answers, and they can tell that you've got your algebraic techniques. But if you also know that you suck at it, then don't try to expand and factorize, because then you're likely to make a mistake. So if you've got it up to this step, maybe try to keep it if you know your algebra is not that good. I encourage that you factorize everything. Because in year 12, you find that the exams, when you do the exam questions, you realize that the only way to simplify further or to get to the actual answer, most of the time they'll need you to factorize and then cross-simplify. So what they're really trying to test is, can you do your algebra? Because remember, in your 4 areas of study, you have functions and graphs, calculus, but the other third is your algebra. They're assessing that too. So most of the time, they will require you to be able to factorize it. So wherever you can, factorize. And if you can't do it well, probably be mindful, be smart on when you should do it and when you shouldn't. Because what you don't want to do is try to factorize it and then screw it up. So you get the right answer and then you expand and you get something wrong, then it's entirely wrong. Yeah, so if you know that you don't expand well or your layout's poor, probably take a gamble and leave your answer as unsimplified rather than try to simplify it and then get it wrong. Does that make sense what I'm trying to say? Yeah, And so if you simplify, if you expand and then try to simplify, but you have a tendency to get it wrong, probably better to leave it as an unsimplified answer. At least you get it right. But if you expand and simplify and you get it wrong, then you get it wrong entirely. Okay? But obviously, what's the ideal? Always expand and simplify wherever possible. All right. That is chain rule. Let's try. This is just me trying to say that you can derive the inside and the outside. Let's try over these guys. Try those three. And then you can check out the answer. Have a go with these three.
These are all the essential steps that I need to show when I do an answer in chain rule.
In the exam?
In an exam or SAC.
In the exam, ignore that top half. That's all you need.
Oh, really?
Yep. In the exam, you will not need those steps there. They would assume that you already know those, and you can jump right to this. But I probably wouldn't use the letter U. I'd probably write it as 2 times 3x squared minus 5 to the power of 1. That's what I do. But that's generally, if you look at the solutions for the assessors reports, they only write probably even that line there. But they'll write that back if you need an intermediate step. What? What happened? There we go. We've got about 4 weeks left to holidays. You know that. Just to motivate you. More than halfway there for term
That
one.
sounds more scary than helpful.
Yeah, it's probably more exciting for me than you guys. You got more work to do over the weekends and holidays. I don't.
That would be 0, wouldn't it?
Which one? Just as a reminder as well, every time you find the derivative, don't forget, all of this is just a technique to find the gradient of a straight line at a point. What I find is most students, after I teach them how to do chain rule, power rule, quotient rule, product rule, they forget what it all means. It's just to find the gradient of a tangent line at one point.
I mean, I just work away with this over here and my phone.
Drop that.
Yeah, I know that one.
Would you say fraction and fraction? Usually no. Yeah, which is what I'm saying. It's too complicated, yeah. But because it's too complicated, then I'm very sure you got quiet. Because the only way to be able to simplify this further is you comp these two together, comp those two together. But they will cancel out. It's too tedious.
What's your problem? You didn't have to consider the correct answer for the middle one.
This one? Most students do 10x.
No.
Yeah. It's actually wrong.
First off, one of your things
The same with you.
second.
Yeah. Yeah, I see now.
So even if you fix that mistake, it's still wrong. There's no mistakes.
What's that?
That's better, but you're still making a mistake.
Mistake. You got something like this.
Yeah, but if you look at this, nothing is that's negative 15 times that, not the bracket times 15. Because when you times that, it's still the bracket. It's technically correct, yeah. You always just keep it out. This is better than
This is like this one, yeah?
Like the whole thing.
The whole thing.
As in like dy dx equals that line. We expect to expand that.
The whole thing. No. So remember, what I was saying before was in year 12, you want to simplify answers. When you expand, that's the opposite of simplifying. So factorizing is simplifying, but they want it in the most simplest form. Technically, my answer right now is not in the simplest form. But what I want to show you is how to push it to the next simplest form, because it's likely sometimes you get a question where to show, and you have to learn how to factorize things like these ones to further simplify down. So I'm going to show you right here, this one here, how to simplify that. If you got the answer I got for B, most students will leave their answer like this, and that's fine. I'm pretty sure in year 12 exam, they won't penalize you unless they were very pedantic and they said in simplest form or in a particular bracket where they don't want any extra terms inside. You're meant to take it further. Yeah. So how do you take this one further? Most students do this, and they make this mistake. They'll write their answers. Oh, I've got a factor of x. I've got a factor of x. So what they do is they say, all right, I'm going to take out x, and I've got x minus 3 to the power 4, 2x minus 3. That's generally their answer, and this one is wrong. That's what I mean that taking that further step to simplify, even if you got that line correct, but if the next line is wrong, you get the whole thing wrong. Yeah. So up until here, why is this wrong? Taking out that x, I'm going to take a slower step. It's all in your layout. The better your layout is, the less mistakes you make. So here we go. Let's take a slower step. It's 5. Now in this bracket, I'm taking out, it's to the power 4, I'm taking out x as my common factor, and it's x minus 3. Can you see what I'm doing there? So inside here, it's all to the power 4, so it's all to the power of 4. And I'm saying take x out as the common factor. That's what I did. Took out x. X times x is x squared. x times -3 is -3x, right? So it's all good so far. And I've also got the other bracket 2x minus 3. But here's the thing, if you want to take out that x, if you want to remove it from this bracket, then you have to do to the power 4. This bracket is to the power 4. It's like saying, back in year 7 or 8, you learnt ab to the power of 4. You would say it is a to the power 4 and b to the power 4. True? I'm separating them. It's the same thing here. You would say x to the power 4 and whatever this bracket is to the power of 4. So what you should be getting is 5x to the power 4 bracket x minus 3 to the power of 4 2x minus 3. See, that's the correct factorizing term, not this. And then what it's missing is x to the power 4. That's where a lot of students make a mistake. Yeah, that's what I meant. The third area of study that you need is algebra. And they want, sometimes they want to see this. Sometimes they want to see, can you factorize inside the bracket, can you take out a factor of x without screwing up the algebra? And that would be one of the techniques that you may be required. It's normally a question 8, question 9 of exam 1, where you got to learn to simplify. And that's where it shows the difference between the students who can simplify it further and then say, therefore, you know, they might have an a and a b variable and they say, find a, find b. But if students get up to this step, and they don't have to get to that step. Yeah? So that's a common one, learning to factorize that x out. But see, if you lay out your questions properly and not skip steps, and you want to make a mistake. See, when I keep the brackets there, I don't make that mistake when I take it out. Yeah? Anyways, that's how you do that. Most of you, hopefully you picked up, you can differentiate the outside, bring the 5 down. That's where I got the 5, 5 minus 1, which is why I got the 4, and it's x squared minus 3x. Yeah? But you also have to differentiate the inside, so derivative of x squared is 2x, and derivative of minus 3x is minus 3. That's how I got my answer here. Okay? So derive outside, derive inside. So derive inside, derive outside. Okay. yu times the udx. You get your answer. Okay. Any questions there? Pretty good? All right, I'm going to scribble this out. You can check your answers. Here we go. You can leave your answer like that. So again, do u dx, so differentiate the inside, that gives you 3x squared. Differentiate minus x, you get the minus 1. Pretend this didn't exist, there'll be u to the power of half. Bring down the half, u to the power of half minus 1. Okay. When you multiply them, see how I do them? I simply write, since that's flipped to the bottom, I have 2 times whatever goes on the bottom. I still have the 1 in the numerator. Times, that's a whole value, so it goes to the numerator. So it's 3x squared minus 1, I multiply to the numerator. And that's my answer. No negative powers. Okay. Technically, you can try to take this out, but it makes it more complicated because you've got a square root. This is an okay answer for 2 marks. They're not going to expect you to do any further than that. Yeah, 2 marks is fine. If you try to take it another step and you get it wrong, you get it wrong. Yeah, for a 2-mark question, this is the method. That's your answer. And they're likely, especially if it's the first question in exam 1, you're fine. This is okay. And you don't need to take any further. It's just too crazy to do, take out the x and you've got x to the power of half and you'll probably try to move it around. You don't need to. Yeah, just keep it as that. That's good. How do we feel chain rule? Does it feel good? It's all right? Yeah? That's exercise 9E. Please try to learn this technique because 9G, 9H, 9I is all the same thing. You're going to be applying chain rule for every one of them. Okay, and when we get there next session, I will make sure that you're just practicing that chain rule, chain rule, chain rule. It's the bread and butter for calculus. If you can't do it, you're going to struggle for every other question, applications and everything like that. So you have to learn chain rule. Okay? All right. You can do more of these if you want. Otherwise, just start on your exercise questions. Yeah? If you're interested, that is an exam question. That's, I think it was a 2011 question. Have a go if you want. See if you can do that. This is what I meant. It'll get you to find C, D. It's all about learning to factorize. It's an algebraic technique. They're assessing your algebra, and at the same time, they're assessing your sort of just functions in general. So f of g of x, that was a composite function. Okay? Have a go if you want. It's a composite question. So state the maximal domain. It's a 4-mark question. Think about it. 4 out of 40. That's 10% right there. 10% in your pocket for chapter 1 question. Have a go with it if you want. It's pretty good. Bunny?
Alright, is that correct? I need to find what the value of A so that both these two work.
Oh, you got that?
Both these, the answer say that it has to be 3 and 2, but I got 3 and 1.
Yeah, because where you get that 1 plus A from?
Yeah. You put the 1 in there, so you got that.
Isn't the one in the beginning of it?
And it has to do
Where
with
did you must be? Like, the 1 plus A must be greater than
Yep.
I have factor by X, but I get
so A is
That's the one I just did with my new actually.
and this one. A minus 2 must be less than or equal to 1.
Yeah.
So it's 2, 1 to 3.
Okay. It's because you expanded them out. That's why. So that's why you always want to
That's the
keep
one
it as
equation,
simplified as
right?
possible. So this one was correct. Now, if you write that out, you would
yeah,
have
because
got dy dx is equal to
like
4
the domain of that is 2,
which is
so I
this
put 2 into
entire
that.
term here. X
I got this.
cubed plus 2x squared plus x to the power of 3. True? Multiplied 2, which you've got 3x squared plus 4x plus 1. Okay? Now from here, this has an x term, which is what I was describing before. This can be broken down to 4x, taking out the x term, then
You
we have x
weigh
squared
1
plus
plus
2x
A
plus
to
1, all to the power of 3. And this one can be factorized
It should just
to
be A.
3x plus 1.
How's it meant to be A?
That's a turning point.
Yep. This is 3x squared.
The lowest point is at A, not 1 plus A.
And then what you can see here is if you cube the x, you can take out the x and it becomes 4x cubed. And here you have x squared plus 2x plus 1
So that's
all
the turning
cubed.
point.
This is 3x plus 4x
No,
plus
it's
1.
X plus A, so it's just the regular.
This is a quadratic, so we might be able to factorize it. So you can see if I factorize that, that becomes x plus 1 squared. That's x plus 1, but then it's all cubed.
Because you just thought of the 1 to 1
4x cubed on the outside, times with this one, this is 3x plus 1, 2x plus 1, and again we can see the powers, this can be 2 times 3, and we get x plus 1 to the power 6, 4x cubed, 3x plus 1,
was a hard
and you've
question.
got, again, times x plus 1, because this is multiplying by x plus 1 to the power 6 times x plus 1, changes that down to
That doesn't necessarily mean
x
the
plus
endpoint.
1 to
You
power
can only take
7.
the endpoint
3x plus 1.
with guarantee.
I did it over the course of multiple days, so I probably was at one point.
It's tricky, and
I
the,
didn't do a
text,
graph, so-
the textbook will take it too far. Some of it is just ridiculous that you don't have to do, but it is nice to know so that when you do the exam, wherever you can, it generally comes out nicer than what you just saw there. That's really far. Like they've taken it beyond, but it's good to highlight the ability to simplify quadratics. Wherever you see quadratics, sometimes cubics are more likely quadratics. So as soon as you see quadratics, see if you can bring it down. Oh, this one? Oh. I don't think I'm going to have to do it myself. Alright, let's do this question. If the function has the rule x squared minus 9 and the function g has a rule, okay, so... Alright, find integers c and d such that f of g of x. So, first thing, f of g of x will have to equal to square root of x plus 5 squared minus 9. And that gives me x squared plus 10x plus 25 minus 9. X squared plus 10x plus 16. Is that 16? Yeah, 16. And then x, 8 and 2. There you go. That's for A. So C equals 2 and D equals 8. And then state the maximal domain for which, so you can't have a negative. Therefore, x has to be less than, actually no, greater than negative 2. And x is less than negative 8. That's B. That one, no, because this is a quadratic where it looks like that. Negative 2 to negative 8. And what we know is it's the y values that we want to put in, yeah? If I chose any numbers between negative 2 to negative 8, it'll give me a negative y value. The negative y value, if I sub it into this function, remember the range of g, so the range of g clearly right now I've got a negative. So the only way I can get positive range is if I choose greater than negative 2 or less than. Actually equal to, less than or equal to. That's a exercise 1E common functions. Is that like an acknowledgement or? Yes, he does.
Yes, I do.
I feel so sorry for you.
Oh, yeah. I know. He's part of our cohort. Right, it's 46. It's one of the 46. We're all in the same crew.
When do we have tests? What's that?
Next term, week 4. I don't know the exact dates yet.
Do we have a holiday?
You have holidays, after holidays, yeah.